It's week number 6 of me preparing for the Google Professional Data Engineering on Google Cloud certification and following the data engineering learning path on the Google Skills platform. I record these videos to document the progress from the beginning until the moment that I hopefully get the certification for professional data engineer on Google Cloud. And since many other people will follow the same path, I thought that it could be interesting for some people to have kind of a learning body to follow along and also do this learning path and prepare for this certification. I think it makes it more fun, creates a sense of company, a group for people who do the same thing, and I guess it's just more fun. I have finished the week number 6 and the course Streaming Data Pipelines. To be fair, it took me, I think, about a month from the point of time when I recorded the progress for week number 5, which is the same as course number 5 in this learning path, because yeah, it's been just a pretty busy month, a lot of side quests, so to say. I got sidetracked and yeah, kind of lost the focus. But moving forward, I plan to get back on course and at least try to complete one course of this learning path in 2 weeks. I think that would be perfect, but yeah, I can't promise because there are other things, pet projects, work, family, all that stuff. Alright, coming back to the main thing here. It was about streaming and data pipelines. I have a list of notes that I did for myself, and the point number 1 that was covered in this course was about PubSub versus managed Kafka service. PubSub is this serverless messaging service that is available on Google Cloud, and this is one of the core technologies that you will use there to build any kind of data pipelines. They also offer a solution for Kafka clusters and workloads in a managed way. It's not serverless as PubSub, because with PubSub you just don't care about anything. You just have topics there, subscriptions there, and you just set it up in a few clicks or with a simple Terraform and just then work with it. With managed Kafka, there is a cluster that you create. It's managed, so updates, security, all that stuff is handled for you, but you still like provision this cluster and it doesn't auto scale by default. So it's a managed service, so the name speaks for itself. And in the course they compare these two services, when would you use which, and the impression that I've got that almost for every new use case, for every new application, you would probably be better off with PubSub. You would use and choose the managed Kafka service. For example, when you have an existing code base, an existing streaming application that you are migrating to Google Cloud, in that case, it would probably be better to just use managed Kafka service so that you don't need to recreate all that stuff from scratch. The next point that was covered throughout this whole course, again, as in previous weeks, it's data flow. It is a core technology in the ETL stack, extract, transform, load, and stands for transform as a go-to service in Google Cloud for T in ETL. It can be used for batch and streaming workloads, but especially for streaming workloads, so it had its own special place in this streaming on data pipelines course. Again, it was used in several labs in this course, but personally, honestly, I didn't devote any time before to learn about Apache Beam, and again, without fundamental knowledge of Apache Beam, it's kind of hard to make this knowledge about data flow to stick in my hand, because yes, you see examples, they kind of make sense when you look at them, but then if I would need to write a data flow pipeline from scratch, I wouldn't be able to do it without learning separately about data flow. So yeah, kind of the learning debt that I accumulate, and at certain point I would just have to look up the Apache Beam separately and yeah, just try to learn a bit about it. Yeah, but so far Dataflow keeps coming back in almost every week, so streaming wasn't an exception here. We covered Dataflow again, specifically a part about Dataflow windows, because it's very tight and coupled with streaming windows, meaning like the time frame of data that you want to process as a kind of bundle or a batch. So you can have moving windows, can have session windows, and they also mentioned like a few use cases, like how to choose the proper windowing type for your use case. Yeah, but I'll stop bragging about it because I think I don't really have a fundamental knowledge about it. Then an interesting point about CDC, change data capture. If you are not familiar, it's like a way for you to connect, for example, your BigQuery data warehouse to certain data sources like operational databases, because it's a super common thing for data engineers to have a replica of the operational database tables in the data warehouse, and you could achieve it like in a bunch of different ways. For example, with like full copying of data like on a daily basis, get it from operational DB, load to BigQuery data warehouse, and if the volume of data isn't that big, you can go a long way with it. But if you need like real-time updates, not just once per day, from your operational database state to be reflected in the data warehouse, you would use change data capture for it, and it would get the changes that happen to the operational database table in kind of near real-time manner. They would be reflected in the BigQuery table, for example. So if certain row gets updated, added, or dropped, you would see this change kind of magically, automatically in BigQuery. So very cool technology. It was covered very briefly here. I don't know, maybe later we will come back to this topic. But anyway, they mentioned it and I think it's great. Then I'll complain a bit. There was a failing lab in this course, meaning there was a lab that I completed end to end. But if you're familiar with Google Labs, you verify progress at the core points throughout the lab. And I think I completed like 70 or 80%, but the final two checks, final two verifications were failing and failing. And yeah, I think there is just a bug which happens from time to time with certain labs on this platform. Probably there is some issue and they just can't verify that I did the required steps. And why I think it's not my issue specifically, because when you face these broken labs, you see their score consisting of stars from 1 to 5. It's usually like 3.5 or something. So the same case was for this lab, because when you encounter a normal lab, it's very rare that the score is lower than 4. And for this example specifically, yeah, the score was 3 or 3.5. So yeah, I was kind of expecting that it will break, and yeah, it did break. But doesn't matter, you still can do the lab. It's just you can't have a completion badge achievement of doing this lab. But yeah, it doesn't matter for our purposes here. Then a cool new concept that I didn't know about. In BigQuery, you can have continuous queries, meaning you can write a SQL query and to not schedule it, but to run it in continuous mode. And it's a cool thing for streaming processing workloads. For example, some events land in your raw table in BigQuery, and you have this continuous query with certain transformations. It's very limited. You can do joins, group by, all that stuff, and you need reservations API enabled and dedicated, connected with this query to run it. So this continuous query runs all the time on the new data that lands in your table, and you can do some simple transformations with this data and either write it to BigQuery or other supported data destinations. For example, Bigtable or other things. Talking about Bigtable, it was another core pillar in that course that was covered, and you would use it for high throughput and low latency read and writes for your production workloads. There we covered like a bunch of scenarios how you would use it, and one that I think is cool and useful is reverse ETL, meaning it's a very common case that you need to run certain analytical queries to aggregate some data to create some insights and show them to the user. And for that purpose, you could kind of expose the BigQuery table for that case. But imagine you have millions of users and every one of them needs to query BigQuery table for their user ID only. And as a result, it's not really a workload that is suitable for BigQuery, because BigQuery is used for analytical workloads, not for frequent reads like for one user ID. And for that type of workload, the Bigtable would be the correct choice. You can just load the data in BigQuery, run a transformation, for example, using this continuous query or in some other way, transform the data to create these insights for analytical dashboard for user, meaning user-facing thing, and then export this data to Bigtable. And then the website, mobile app, or just some game would query the data from Bigtable. It would result in low latency, fast reads, and you would have this reverse ETL process where the data comes in BigQuery, gets transformed, and then gets exported back, for example, to the operational database that could be Bigtable. So yeah, a cool architecture for such a popular task. And they have a small, tiny honorable mention for a kind of small technology and nuance called Bigtable Data Boost, because in quizzes that were throughout this course, it was mentioned several times. And I think it's cool and important to know about it, because maybe it could be asked during the certification exam, or just it's good for you to know it. So what does it do? It's also a possibility that you have your operational data in the Bigtable, for example, and it's still possible and allowed to try to do some analytical workflows on that data residing in Bigtable without replicating it to a data warehouse like BigQuery. So it can still be done, but it needs to be done in a smart way. So for example, you have an application with this database and it's like loaded heavily. It doesn't stay stale or like unused. But you have a data analyst that needs to run a certain analytical ad hoc query on the fresh data residing in the operational database. Because it's an ad hoc request, you wouldn't really copy the data from Bigtable to BigQuery just for that. Or maybe you have a batch uploads to your BigQuery data warehouse, but the analyst needs fresh data. So it doesn't make sense to build like a whole new system just for that one ad hoc request. That means that a data analyst would need to be able to run the analytical query on the Bigtable itself. And we can do it in several ways. The worst way would be to give access to the data analyst to the Bigtable itself, and then he would just run the queries against it directly, which is also an option, but there is a better way to use external tables, Bigtable, Big Lake table in BigQuery as an external table that is connected to production operational table in Bigtable. You can write in comments how many times I said the word table, and then give the data analyst the access to this big lake table. With that, this analyst would be able to operate within BigQuery and query the operational database Bigtable. I'm bragging too much because I have said so many things and haven't reached the main point I want to talk about, the data boost. So with all that setup that I have mentioned, our Bigtable is heavily loaded, our core users query it for their data, and it needs to remain a low latency service. The risk with running analytical workload on it that the core users would experience an increased latency. And the way how we can avoid it is with data boost. So by enabling the data boost, when our data analyst queries the big lake BigQuery table that is under the hood using Bigtable, the data boost would provision the separate computing resources just for this new analytical workload. So these new computing resources would be decoupled from the core compute resources that are used by our core users that queried the Bigtable tables in the operational manner as an operational database. Putting it in other words, Data Boost is a provisioning of separate compute resources on demand for certain ad hoc or maybe even scheduled queries for Bigtable as a way to avoid increasing latency for the core users of the Bigtable. So I think it's nice. There were a bunch of questions and quizzes about it, so that's why I have noted it as a separate point. And this is it. It was a week number 6. Thank you so much for watching, and see you in a few weeks for week number 7. Have a good one.